2.2, the area between curves. In this next section, we're going to discuss how to determine the area between two curves. So what that means is we're going to integrate both functions and determine the area between them. So my goal then is to find this area inside of here. Well, we know if we integrate our red function, which is sine of x plus 3, you get all the area underneath the red curve. And if we integrate the purple function, you get this, which is the area underneath the purple curve. So if you want the area in between, what you do is you integrate the red one, and then you integrate the purple one, and you subtract off this area down here to get just the inside. Just this. So what you do is you integrate both pieces, and you simply subtract off the piece you don't want. This leads me into the definition of how to find area between curves. So we started with an integral like this, and we ended up with an integral like that. So area between curves. If f and g are continuous functions with f of x being strictly greater than or equal to g of x on an interval ab, then the area between the curves y equals f of x and y equals g of x from a to b is the integral of f minus g from a to b. And so we write that as the integral from a to b of f of x minus g of x dx. Some people also refer this as the integral from a to b of the top function minus the bottom function. Example 1. Determine the area of the region between y equals secant squared of x and y equals sine of x on the interval 0 to pi over 4. So step 1 is to graph the curves to find their relative positions on the plane. We do this to determine which one's going to be the top function and which one's going to be the bottom function, or which one's f and which one's g. So if we graph these, we get secant squared is right here. And if we graph sine of x, we get this. So we have that secant squared is going to be our top function, and sine is going to be our bottom function. And now what we want to find is this area. We want to find the integral between them, so we want to find the area between these two functions. So having graphed those, I find it very helpful to graph them on your own paper, identify which one's which. So this is secant squared of x, and this is sine of x. And then go ahead, and I actually like to draw out the area between them. Alright, so that's done. And I want you to notice something. So I want you to notice that y equals secant squared of x is always above the graph y equals sine of x. Now step 2 is to write an integral and solve. So for this integral, we get that the area is equal to the integral from a to b of f of x minus g of x dx. And I'm letting f of x be my top function and g of x be the bottom function. So I get the area is the integral from 0 to pi over 4, because the integral is from 0 and it ends at pi over 4, of secant squared of x minus sine of x. And if this is a calculator portion, you can go ahead and just put that in your calculator and you're good. If it's not, we need to know how to do it by hand. So we get the area is equal to the integral of secant squared is tangent, and the integral of sine is negative cosine from 0 to pi over 4. So we get this is equal to tangent of pi over 4 plus cosine of pi over 4 minus tangent of 0 plus cosine of 0. So you get this is equal to 1 plus root 2 over 2 minus 0 plus 1. This is 1 plus root 2 over 2 minus 1. And so you just get root 2 over 2. Now keep in mind we need to talk about units. We don't know if we're in meters, feet, so we're going to write units, and it's units squared because we're dealing with an area. So now on your own, I want you to try to determine the area of the region bounded by the curves y equals 2 and y equals cosine x plus 1 on the interval 0 to 2 pi. So I highly recommend you graph this, and I'll show you the graph before you pause the video, but you're able to do this on your graphing calculator. Alright, let's see what we get. So what I like to do is, like I said, I like to color it in. If you haven't noticed now from watching my videos, I'm a huge fan of color. I also want to point out some of the intervals. This is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. My top function right here is y equals 2, and this function here is y equals cosine of x plus 1. So now all we have to do is write the integral. It's the integral from 0 to 2 pi. My top function is 2 minus the bottom function, which is cosine of x plus 1 dx. So when we integrate, we're going to get 0 to 2 pi, and 2 minus 1 is 1 minus cosine of x dx. I actually chose to combine like terms before integrating. Now I'm going to integrate, and I'm going to get x minus sine of x from 0 to 2 pi. So this is 2 pi minus sine of 2 pi minus 0 minus sine of 0. Don't forget those parentheses. So this is 2 pi minus 0 minus 0 minus 0. So your answer is just 2 pi units squared.